In this video, I will be showing you how to evaluate some truth tables, and the emphasis, though, will be on how to use the TI-84 graphing calculator to evaluate these truth tables. So the first thing I want to cover is how does or what commands are available on the calculator for Boolean logic, and we have the three commands, or the three logic statements that are covered in the textbook that are included on the calculator. We have the AND statement, which corresponds to A and B here. And again, this is just a clip I took right out of the textbook. A and B means elements are in the intersection of A and B. Here's the OR statement, A or B. That would be the union of A and B. And then we have NOT. And NOT refers to not A, and those are elements that are in the complement. The calculator also has this exclusive OR statement. Generally in math, we think of the OR statement as inclusive, meaning that we can have elements in both sets, or that the intersection includes elements in the first set, the second set, and also in both sets. The exclusive OR means that we don't count elements that are in the intersection here as part of the union when we do the OR statement. And I can give you a demonstration about, and show you how this works on the calculator. I'll also show you how we get to these commands, or these statements. So let's start with 1 for true, and I'm going to go second math, and then arrow 1 to the right to get to the logic statements. I'm using the OR statement. So true or true, and this is the inclusive OR now, would result in a true statement back. If we do true or false, again, we get back true because we're talking about the union here. So only one of the statements has to be true. Now, interestingly, if I do use that exclusive OR and I evaluate the statement true or true with the exclusive OR, this time I get back 0 for false. The reason is because this is an example where we are excluding the possibility of the intersection. Again, the statement comes back false with the exclusive OR. But if I use the exclusive OR on the previous statement, or on the final statement here, true, exclusive OR, false, I get back true, because only one of those statements is true. So again, I don't think there are any examples in the book using the exclusive OR. I just wanted to show you how that would work on the calculator. Now let's take a look at a truth table here. And again, these examples I'm taking out of the textbook. For this example, this is example, or try it now 4. And basically what I have here is I have condition A, condition B, true, 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 false, false, true, false, false. Those are all 4 combinations of what's possible for A and B if we allow the statements to be true or false. Now the complement of A is, we think of it as not A. So if A is true, not A would be false. And again, if A is true, not A would be false. If A is false, then not A would be true, and not false again would be true. So next we're going to look at the intersection. So in order to be in the intersection, the element has to be in both not A and also in B. So these are the 2 columns I'm focusing on right now. So for the intersection, true and true would be false, because they're going to have to both be true in order to be in the intersection. And if they're both false, again, we have false. If B is true and A complement is true and B is true, then the intersection is true. And then similarly down here we have false again. Now we're building up to evaluating this goal. This is kind of our goal, is to evaluate this statement. And so we've gone from, we're working from the inside out. We've got not A, and then we have not A intersect B. Now we're going to take the union with B complement, or not B. So I'm going to make a new column for not B here. So if B is true, then not B is false. And I'm being really careful here because it's very easy to make a mistake. I mean, one slip of your thoughts here, and all of a sudden you've messed up the whole table. And this is where the calculator is going to really be nice. I'll show you how to use that in the next slide. But in any case, so now that I have these two components done, I'm going to look at the union. And this is, again, the inclusive union. So we're going to also count the intersections here. So if not A intersect B is false and the complement of B is also false, then the union is false. If it's a real mouthful, but if the complement of A intersect B is false, and we take the union of that with true, then our statement would be true. So we have true or false, true, false or true is true. So this is how we would create this table if I were just doing it by hand. Now, to do this problem on the calculator, what I need to do is translate the T's and the F's, or the trues and the falses, in the previous table to ones and zeros, which I've done here. So again, I could fill this in. Let me get my pen back. So I could just fill this in by looking at what the complement of these statements would be. But part of my goal here is to check my work. And so I'm going to show you how to do this on the calculator. So in order to do these computations in an efficient way on the calculator, I could do them one at a time, and maybe I'll show you how an example of how to do that first. We'll seem kind of, I think it'll seem kind of inefficient to do it this way. But if A is 1, which is true, then not A would be 0. So we would put a 0 here. And again, we're looking at A. So not A would be, again, 0. And then if we did not 0, we'd get 1. And so again, I'm not going to go through all that on the calculator because I want to show you how to do all 4 of these at one time. And in order to do that, we're going to use something called the list editor on the calculator. And this is something that'll come up. We're going to do a unit on stats in a few weeks. And so using these lists for data will also be another application. But right now, we're just looking at truth tables. So I'm going to show you how to do that. To access the list editor, I'm going to go to Stat. Just press the Stat button and choose the very first choice that comes up, which is Edit. Now I've got all kinds of stuff on my calculator here. I don't know what this is. I don't even really recall what all this stuff is. Your calculator screen when you go to this place is going to be different, inevitably. And if your calculator is brand new and has never been used, then you probably are seeing L1, L2, L3, L4, L5, maybe even L6 across that top row. And there's nothing in the list. Or if you're renting the calculator or you got the calculator from a friend, who knows what the history is, you might have some numbers in these lists. And they might be in a different order. None of that really matters for what we're going to do right now. So right now what I'm going to do is I'm going to create a new list and give it a name. I'm going to take you through the step-by-step process. So in order to insert a list, now I want you to notice that my cursor, or what's highlighted, is this first entry in L1. So in order to do what we need to do, the cursor needs to be all the way up here to the top. And just to pay attention to what's going on, you notice the calculator switches its notation when I go from one spot to the other spot. Notice here we have L1 of 1. That's entry 1 in list L1. It's a number. If I go to the very top, if I click up arrow once, notice it's throwing in these braces for set notation. So when I'm in when I have my cursor all the way up here to the top, then I have the entire list selected. Now I'm not really at this point going to do anything with list 1. Eventually we will. But for now, I want to insert a new list. So I'm going to press second delete. And notice INS is what's written above that in blue, which means insert. So what I've done, or what I've told the calculator to do, is to insert a blank list. Now it's waiting for me to give it a name. It's possible that when you do this on your calculator, you'll see an A in the cursor automatically. Some of the calculators are set up so that they are in alpha lock mode, and all you have to do is type the letter. So mine's not in alpha lock mode. If yours has an A, then all you have to do is type this key and it'll type an A. I don't have the A, so in order to get it, I'm going to go alpha. Notice the A now pops up. I type an A because I want to call this list A, which is going to correspond to my table. Now notice also when I type the A, the cursor no longer has the A. So if I went to type another letter, it wouldn't type the letter. I'd have to press alpha again. We can alpha lock though, and then the calculator will only type letters. And I'll show you how to do that down the road. Now in order to create the list, I'm going to press enter, and I now have a list named A. And that corresponds to the A column in my table. So next thing I'm going to do is enter the 1100 in column A. And I just did a down arrow because I need to come down now into the table to enter these values one at a time. So I press a 1 to enter 1, 1 and then enter, 1, enter, 0, enter, 0, enter. So I've just inputted the column from the truth table A. Now I'm going to do the same thing for the B column. And again, notice I'm navigating around in the editor using the arrow keys. And now I'm going to do another second delete to insert another blank list. I'll call this one B. And I'm going to arrow into the table, and I'm just going to enter those values that are in column B on my truth table in the example. Now I could create new lists for each part of the table if I wanted to, but I'm gonna use the list L1, and incidentally L1, L2, L3 up to L6. Those are all lists the calculator just has built in. They're convenient because we can access them right off the keyboard here. But in any case, and we'll do that down the road. But for now, I'm just interested in using it as a temporary place for my logic outcomes to be stored. So I'm just going to clear out what's in that list and press enter to complete that operation. If you have nothing in L1, then you're set to go. If you have some numbers in L1, you can clear them out the way I just did. So now we're ready to start going through the truth table. So one thing, the first thing I'm going to do is, I'm going to show you how to do not A just because it's worth seeing. I'll probably skip not B because it's such a straightforward thing. But if I wanted to create the truth table list for not A, notice again I have my cursor all the way up at the top. I'm going to do, and what that means is whatever operation I'm going to do is going to happen to every element in the other list. So I'm going to define L1 as, just press second math, go to logic, and I'm going to use the not option. And now I have to be a little bit, careful here. If I just type an A, I'll get it. I believe I'll get an error message. I haven't actually tried it. I think I'm going to try it just for the heck of it to make sure I'm right. So I'm just gonna I'm just gonna do this, and yes, indeed, I get an error message like I expected. So what's the issue? Now, one of the nice things on the calculator is when you get these error messages, you get an option to go back or to go to the mistake. So I'm going to choose go to, and what it's saying is there's some issue with the not a statement here. And I know what that issue is. I am not telling the calculator to use list A. It's got some other value stored in A. And in fact, again, you don't need to do all of this on your calculator. I'm doing this just as an example. If I look at what's actually stored in A, it's a 0. So this is interesting, but if I did not A on the home screen, then I would get back 1 because not A is 1. Notice that if I do not A, so I'm going in here to get not, if I do not list A, and I'm going to find that list by going second stat, which gives me all the lists that are in my calculator. Notice it gives a little L now in front of the A. So that distinguishes between the variable A, or the unknown A, or in this case A was defined as 0, and the entire list for A. Now notice what happens in this case. I get a set back, a whole set. And so that set is, if you recall, what would be in A complement, 0, 0, 1, 1. And we can do this right on the home screen. But I like to do it in the editor because you can kind of see what's going on. It kind of mimics what we've got in the table. So I'm going to go ahead and go back to the editor, and now I'll show you how to do this. So I go all the way to the top again, highlight the whole list L1. If my cursor's here, I'll get an error. I need my cursor all the way to the top, and I'm going to go second, math for test, over to logic, choose not, and now I'm going to go second, stat for lists, choose number 7. I can press the number 7 as a shortcut, close the parentheses, and it fills in that column. Do the same thing for not B. I'm going to skip that one. I want to focus on the not A intersect B and show you how to do this column. And we'll come back and we'll fill all this stuff in the table here in a minute. So again, I know this is a lot of steps. Keep in mind you can back up the video and play it forward if you need to go back if you're not able to follow along. Okay, now I'm going to clear again everything out of list L1. And I want to show you a little trick. The calculator actually has the ability to archive and store functions we put into that we define lists with. It's actually a lot like Excel. The way we do it on the calculator notationally is different. So notice here above the plus key in green there are some quotation marks. If I put the truth statement in quotation marks, okay, I'm going to start with a quotation, and to evaluate the complement of A intersect B, what we would do is we would say not, and I'm going to do the whole list now, so I got to go second, list, choose A, and remember intersection, that corresponds to the and, so we're going to go and I'm going to get and. Now we're going to take the union of the complement of A and with B. So now I need list B here. And I don't need that parenthesis. So for now, I think I'll go ahead and leave. Well, all right, I'll just leave that off for now. And so what I'll do is I'll close that quotation mark, which is something we need to do that. All right, now when I press enter, notice I get the same answer we got previously, which was false, false, true, false. So if I wanted to go, and I'm going to switch over the table now. I'll illustrate here. So we'd have 0, 0, 1, 0, and this would be 0, 0, 1, 1, and this would be 0, 1, 0, 1. And again, this should be the same thing I was getting in the previous table, but instead of T's and F's, now I have zeros and ones. Now this last one is a little bit on the a little bit complicated looking. And I want to go back to the calculator and show you how we would evaluate this statement. So here we have the intersection of A complement with B, and then we're going to take the union of that set with the complement of B. Now when I arrow back up and select the entire list L1, notice now it's defined as a logic statement, which is kind of cool because now I can go in and edit this statement. And now I'm going to go ahead and put this in parentheses. I'll be honest, I'm not totally sure I need these parentheses, but when in doubt, put them in because redundant parentheses is not necessarily a bad thing. So I'm going to go ahead and put, and it kind of mimics what we're seeing here. So we've got the set or complement A or not A and B parenthesis. Now we're going to take the union, which is going to be represented by OR statement. So I go back to the test menu now and choose number 2 for OR. And then we'll say complement B. So that's going to be not B at the end. So I go second, tests, logic, not, second, stat, and then choose list B. Close that parenthesis. I believe this is correct. Let me double check it. So we've got not A, which is the complement, intersect, yeah, that's right, B, and then we've got the union, which is an OR with the complement of B. Okay, so that looks right to me. So I press enter, and then we have false, true, true, true. So I believe that's the same answer I got before. And that would, again, if we're using the 0, 1 notation, that would be 0, 1, 1, 1.